We are ready. So, hope you guys have been enjoying the conference so far. It's a pleasure and an honor to speak in front of you, Vegas, almost every year. My name is Saumil Shah. For the next hour and 15 minutes, or however soon it is that you get bored, I shall be entertaining you about the mysteries of HTTP fingerprinting. So, without much ado, let me get into this talk. Here we go. So before I get into nitty-gritties of HTTP fingerprinting and such, I'd like to share with you what is our scenario. What are we targeting? It's web servers. We're targeting web servers and trying to find out as much as we can about the different components of the web. I used to be a Unix hacker, hack Sun RPC and stuff, and somebody got the silly idea of putting firewalls in front of everything. God knows why they did that, so almost tried to force me out of a job. But so the hole gets narrower, and all I've got left to work with is HTTP. So that's where I've been spending most of my focus areas on, crafting all the attacks and enumeration and techniques over HTTP. This talk is not so much about attacks, it's more about trying to identify or enumerate things as much as we can. A lot of concepts for especially the first half of the talk are in a parallel with OS fingerprinting, thanks to our friend Fyodor. I don't know if you're here, I saw him here a short while ago. But I have been inspired by his work and Ophir Arkin's work in operating system fingerprinting. So here we go. Pretty much this is the scenario we're looking at. We have a web client which can only send HTTP requests to the server and receive HTTP replies back. Everything lies behind the firewall. So all we got to do is work with HTTP, layer 7. We don't even talk packets here. So as security has evolved, there's a lot of, we were talking about web hacking a couple of years ago. Everything started moving away from OS services and got all onto HTTP. Big deal was made about web hacking. I was one of the guys who made a big deal too. But then web defense has also evolved. 4 of the main areas in the evolution of web defense where things have improved is, one is web server configuration. It's like a lot of effort has been spent on making web servers tighter by default when it comes to default configuration and installing. Then few people came up with web server plugin filters. So you have an ISAPI DLL that gets thrown in. You have an Apache shared module gets thrown in. And these sit in front of your web server, or rather logically in front. And they intercept the incoming HTTP requests, perform analysis, and do whatever it is that they do. The third theory is secure coding. I don't know what the whole deal is about secure coding. But yeah, that is a good remedy to fix web holes. Few people use it, and those who use it, it's very effective, of course. And the fourth, however, it gets pumped out in the market a lot, is security by obscurity. Well, if you don't know something, what it looks like, you can't hack it. But that's when, when we come into the picture saying, we can take a finer look and uncover what lies behind the obscured stuff. So a lot of HTTP fingerprinting is also just to defeat the principle of security by obscurity. Another application of fingerprinting is just inventorying, getting to know something better. So security by obscurity, I've asked people, do you guys run IIS? And even if they do, they say, no, I don't run IIS. But one of the main theories whenever we begin assessing web applications or web servers is try to find out what the server is and what's running on the server and what's running behind the server. And so far, most of the techniques rely on banner grabbing. You connect to the HTTP port, you send an HTTP request, head, get, whatever it is, have you. Look for the server response, and then try to sift through the server response and look at what the server string is. In our case, it is Microsoft IIS 5. And then we just go by the string, assume it's a Microsoft IIS 5 server, and attempt to profile it in the means that we would go about profiling an IIS 5 server. Start looking for Microsoft vulnerabilities or configuration issues or such. Now, what if, excuse me, confounded phone annoyed me. It's hard to talk like with phones blinking and vibrating in pockets. Uh, sorry. Okay. So one of the things that people did is, well, what if people can't figure out this is an IIS server? Sure, I have IIS, I've paid lots of money, had all IIS ASP deployed all over. Can I try and disguise it to keep attackers away? So one thing you can do is you can patch the web server binaries, change the web server banner. So instead of IIS 5, you hex edit the DLL, bypass the security restrictions and say it's Apache 1.3.26 or whatever. Sometimes if the source code is available, let's say you're really running an Apache server and you don't want much attention attracted to you, recompile it and say it's a Lotus Domino server or whatever it is. And in this case, it works great, keeps 90%, 95% of the attacks away, especially those which are scripted up or those which are automated. And this is like the principle of security by obscurity in servers. In some cases, there are even products available, like Server Mask 2.0. It's a plugin to IIS, which will not only just change the banners on the fly, it will go ahead and do things like reorder the order of HTTP fields, like date will be put in front of server and server. The order of fields, like server goes before date or date goes before server, will be changed around. Things like Server Mask can do things like not mimic many other server banners. You don't have to go patch binaries. If you have the web server configuration rules available, like Apache, you can do mod rewrite and rewrite many parts of the header. So that way, that's like the way people go about disguising servers. So what do we have then? We come, like, this forms the basis of HTTP fingerprinting. So the objective is to accurately determine the underlying web server platform, despite any obfuscation, despite any such tampering or tinkering. And while we're at it, we can also try to attempt any plugins or application servers that fit in together with the web server. Then there are some web-enabled devices, like your wireless access point, your printers. They all give you a web interface. These devices do not return what type of device they are. Sometimes they don't even have a server header field in there. So we can perhaps extend fingerprinting to detect these. And the whole underlying idea is HTTP fingerprinting works only because of implementation differences or assumptions made while implementing HTTP from vendor to vendor. The spec, the protocol specifies precisely what the responses have to be if the requests are well formed. If the requests are not well formed, it is left to anybody's guesswork what they want to respond with. This also forms the basis of stack fingerprinting and OS stack fingerprinting. So what if I send a request with, say, get HTTP 9.0 to a server? Like if you were writing a web server, what would your response code be? The spec doesn't say that, so you just pick whatever idea you have at the moment you're coding it up, and that would be your response. Well, different people have different ideas, so Netscape server will respond with something else, Microsoft will respond with something else, Apache with something else. So that's where we begin detecting differences. So the fingerprinting logic, now this is fingerprinting in general, not just HTTP. The three theories to fingerprinting. One is you can have a decision tree based method. It's more like a chemistry experiment. You have an unknown substance, you throw sulfuric acid in it. If it turns green, it's this. If it turns red, it's this. If it blows up the lab, you're dead. And then, if you survive, you go ahead further. So you take the other part of the substance and dip it into some sodium hydroxide and keep going from there on. Then there's statistical methods. It's all probabilistic, frequency-driven stuff. Lots of equations can be written on it. Hence, a lot of papers can be published on it. And then there's the neural network-based methods. So the whole catchphrase of fuzzy logic comes in. People love that. So you train your neural machine to recognize signatures and such. Uh, all these things have their merits and demerits. Um, I do not profess to have the best technique. I have just something that works. Uh, and as far as implementing these techniques go, the fingerprinting engine, there's three components to the fingerprinting engine. The first and the most important is your set of test cases. You have to carefully choose what tests you want to run. The ideal is you have to optimize. You don't run too many tests because you don't want to waste time. You don't fall short of any tests because you don't want to compromise on accuracy as well. And then you have, if you have a decision tree based method, you have a response tree, a chart, so saying test one run, result is this, follow this path, test two, so on and so forth, you drill down. If it is statistical or neural network based, you have weight vectors, so you generate a set of arrays which have different weights, and you compare unknown responses with the respective weights, and then the best weight wins. Something like that. I don't want to drill too much into maths or computer science at this point. Yes, a second. So yeah, the fingerprinting techniques. Some of the techniques which I have covered, the first and the most obvious is any deviation from HTTP RFCs. RFCs preach, but people do not practice that. Sometimes they decide to do things their own way. So if there's any such deviation in implementation, that gets detected first. Then there is behavior that is not specified by the HTTP RFCs, especially behavior when handling errors. The third technique is default behavior. You look for the presence of, say, /CGI bin or /scripts or something. Default installs behave in default manner. Fourth is header field order. Like, does the date come before the server comes before the date? There's many other things in there. Any implementation peculiarities, spellings, like just the way things are, the way e-tag appears or something like that. Error analysis, if you send like an extra messy string with like say 2 query strings, 3 query strings, does it give you an error? Does it give you a denied? What so? Any peculiar cookies that leak out, ASP session ID, CF ID, JSP session ID, etc. So these are some of the techniques. There's a paper put up on my website as of this morning, which gives you some more details into what I've done. Just a brief introduction to HTTP fingerprinting. Accuracy in fingerprinting is key. It's all worthless if you can't make it accurate. The factors that affect accuracy are the choice of your test cases. So what tests have you picked to try against the server? Decision trees are hard to scale. I first started off with a decision tree based approach, and then as I kept on encountering different servers and want to add them to my list, I have to rewrite the whole tree. Sometimes, like if the test is way in the middle of the tree and not nearing the leaves, then the paths change too drastically. And if I'm coding on a tree based, I just have to rewrite too much of code. So I dropped that in favor of a weighted, like a sort of a statistical or a neural system. And I go by weight vectors, which I will show you. And there's a little scoring system, how I add up the weights and compare the weights. And then I had to train the thing to recognize signatures or derive stable signatures for each type of server that I want to detect. And this input set will be used to compare unknown signatures against. It's like an interesting paper that I came across when researching neural networks. Like, I think the British government had made a system which recognizes aerial photographs taken from aircraft. The photographs contain tanks laid out on the field. So the neural machine was used to detect if there's a tank in the picture or not. And the thing was trained accurately and kept on working very well with thousands of pictures which either had a tank in them or did not. And then when it was set to the field, the thing used to fail miserably. And they tried to analyze what happened. They found out that all the pictures that had tanks in them had gray skies, like dull, dismal days, and all the pictures that did not have tanks in them were bright skies, So the system was instead recognizing daylight from cloudy weather instead of tanks or no tanks. So you can run up against such things when you do neural networks. And it, believe me, like couple of weeks in April, I was driven crazy by just this phenomenon. Anyway, so let me, I have some examples to show you. I think it would be best to do it with a demo. So give me some time while I pull out my demo. Here's the demo. And I'll also brag about the HTTP fingerprinting tool at this point. Wireless mics are much better. Okay. Can you guys read all the letters properly on the screens? Guys at the back? Okay, cool. So I have two servers, three servers actually over here. 192.168.7.237. What the heck is that? Okay, no noise. There's this two servers out here, 192.168.7.63 and 192.168.7.237. So let's first see with traditional techniques what these servers are. Then I'll introduce you the tool, and then we'll go on to disguised servers. So let me, you guys all familiar with Netcat? Anybody not familiar with Netcat, please? Okay, no problem. Just one, read up about it. It is a very, very good tool. Never be without it. So let me, Netcat 192.168.7.63, port 80, head HTTP, oops. Hard to type and hold the mic at the same time. Okay, there. Does the wireless mic work? Anyone? No. Okay. Okay, so this says the server is Apache Advanced Extranet Server. So it's Apache 1.3.23. We just look at the banner and figure what it is. Next, let us try the other server at 237. 1.0. Yep, saw that. And this says it is an IIS 5.0 server. Fine, so far so good. Now, let me introduce you the tool HTTPrint. What I've written is a command line tool called HTTPrint, which identifies to do HTTP, which attempts to do HTTP fingerprinting. So it takes, you can give it inputs either as a host on the command line. It can be an IP address colon port, or full HTTP URL, or it could also work on SSL. You can also have an input file, a text file containing a list of hosts to run in a batch mode. Then it requires a signature file, the set of signatures that it has been trained for. And you can give an output option to dump results into a very slick HTML file. So let me just show you let's just create an input file and put these two servers in there. Okay, this 237 has already been there from my testing, put in .63. Save this. So run httprint -i input.txt. Output file, let's just call it as fp1.html. And have a file called signatures.txt, which comes bundled in with the tool, like a set of signatures that I have gathered painfully throughout the past few weeks. So let's just run this, and I will give an option -p0 to turn off ICMP. Like if you're doing a range, it's good to have the ICMP enabled because it'll ping the host before it goes profiling them, but you can turn it off. I'll just turn it off to save some time. So it set loose on 237. It'll send like few 10, 12 HTTP requests, and it'll come back with all this fancy output. Okay, let's walk through what the fancy output is. It derives a signature. This is what the server came back with. The server header, Microsoft IS50, and this hex encoded signature pattern. It says the banner reported was IS 5.0, what came back from the server, and the banner deduced is what the engine thinks it is. So again, it is 5.0. So I just did this as a litmus test to prove that it's all accurate. And below here, you see all these weights. So currently, the engine recognizes all these servers that appear, IS4, IS5, IS 5.0 with .NET, 5.1, 6, Netscape, Sun1, Apache, Zeus. I've got some Domino and Cisco Linksys stuff, anything that I could lay my hands on. And against each of these signature titles, you see a weight. Like IS 4.0 scored 115, IS 5 scored 162. And the theory is like the highest weight wins. So IS 5 got the highest weight. It was deduced as IS 5. There are a couple of catches to this technique. Like if a server is not in the list of signatures, even then the best server wins. So sometimes if you get if you're trying to profile my own web server 3.0 or some unknown server according to the engine, it'll say this is IIS6 or Linksys access point. That's not a false positive, it's just that the signature isn't there to compare against. It can only detect stuff that it knows about. Anyway, so going on to the next signature, it's Apache. The banner reported Apache 1.3.23, and the banner deduced was any Apache between 1.3.4 to 1.3.24. So that's how the scoring stuff works. But wait, let's see the report. It's in consulting or in pen testing. You guys know it's all about the report. The fancier the reports, the better you score. And my free tool gives you damn fancy reports. So use it, earn some money, send me some postcards, buy me ice cream if you like it. There, how do you like that? So you got the host in there, you got the port, SSL, yes or no, banner reported, banner deduced, and if you got a little GIF file, it will also throw in a little picture in there. You can specify the GIF file in signatures, capture the GIF out of your favicon.ico files and make like a real slick graphical pretty report. So this is the report that we get back, but wait, there's more. This tool not only runs on Linux, runs on Mac OS X, and get this, it runs on Windows. And it has a Windows GUI. How do you like that? Let me show that. Open up Virtual PC. Okay, before we get into the Virtual PC thing. Yes, that is a Windows 1.0. I do have a working Windows 1.0 on the Virtual PC. You guys can see it after the show. Okay, while this is going on, Let us now turn our attention to another server. Well, we'll turn our attention to 192.168.7.237 and 238. 237 is an IIS 5.0 server. What we're going to do is log in via terminal server and enable server masks. So we'll go ahead and obfuscate that and see how our tool performs. Okay, let's come up. And there's server mask. Let me enable it. Enabled. What should we masquerade as? Apache, Domino. Let's take Domino. Apply, Domino, restart IIS, sure. It's restarted. Minimize. Virtual PC is booted up in the background. Let's just go ahead and do the netcat and see what it comes back with before we do HTTP print. So I'll do netcat on 7.237, HTTP 1.0. Comes back as Lotus Domino, as you can see from the server banner. It's fine, so server mask at work. Let us try another server, 238. This one actually has most of the fluffy headers stripped away. Like a bare bones server, it reports itself to be Netscape Enterprise 6.0. Nothing else is leaked out except like the date and the server, connection and content type. So it has a minimal set of headers. Remember, with HTTP, unlike the operating system stack, you can do a lot of customization. You can turn off HTTP request verbs, like you can just all of a sudden deny head, deny post, deny put, or something like that. You can customize responses, you can strip away headers. So it's quite difficult. It was like a challenge for me to come up with this fingerprinting engine, but there's enough points of control and enough statistical gibberish that I did to improve its accuracy. So okay, these two servers are there. Let's see what, now we'll try to fingerprint them through the GUI tool. Let me log in. And I'll open up HTTP print. Come on, Windows. So here's the GUI. There it is. So this is the HTTP print GUI. Nice, slick, one-panel job. I have a file. It picks up input.txt, signatures.txt by default. Or you could go ahead and add the host directly if you want to do it manually. So let's do that. 168.7.238. Next one is, oops, stop. 192.168.7.237. So there we've got these two populated. Let's hit the play button. If you look at the options tab, there's options to turn off ICMP, increase, decrease timeouts. These options are also available in the command line tool, so you can customize them as you please. And now it comes back and says HTTP print completed. So the first server reported Netscape Enterprise 6.0. In reality, it is an Apache 1.3.x server from 4 to 24. So the tool caught that obfuscation and reports it as Apache, including the nice little feather. And the second server, which was IIS running on server mask, got caught as IIS 5.0. So server mask is unmasked. If you look at these other two panels, this is the signature, displays it in the GUI. If you're profiling servers that are homegrown or not in the database, feel free to cut and paste from this, paste it in the signatures.txt file, and you keep on extending HTTP print to whatever it is that you like and want to extend. And the panel below gives you all the scores for that particular server. You go to the next one, it gives you the same thing. You can save the report. It creates a file called httprintoutput.html by default. You can save it, and I'll save it as fp2.html. And we can once again, what on earth? Where did it go? Oh well, maybe I screwed up. Okay, anyway, this is the output. It comes, it's like the exact same report generated by the command line. There's a Windows command line as well, so for those of whoever wants to script it up and hates the GUI like I do, feel free to use the command line. Let me also take this time and walk you through the signatures.txt file, how you can work with it. The file is pretty simple. Comments begin with a hash sign, and each signature is just thrown in like this. There's the title that will appear in the banner deduced. There's a signature gobbledygook in there, and if you optionally want, you can have an icon. IIS4_5.gif is the icon that I have for IIS, and I have a little images directory which has all the icons in it where the HTML just throws them out. So just for slickness sake, and you can update them. Some of these signatures are still unverified because I do not have the money or the luxury to own and profile many servers at leisure. If you guys come up with new signatures, I'll keep on adding them to the public signatures database. All this is up on a website, which I will show you at the end of the show. You can download it from there, play with it, and there's a little mailing group if you find bugs or anything, and you want to give us signatures or money, send us email there. And one last thing about, okay, let me just minimize virtual PC, get back to this. Let me show you some other things. I mean, just one more thing about the HTML report. In addition to the HTML, I'm also dumping the signature and the scores as HTML comments. So for all you Perl fans or sed or awk fans, you can cut and grep and lift these up by regexes if you want to derive your own report. Somebody told me, like, why not do it in XML? And I said, I hate XML. I mean, I'm a Unix guy, man. Don't bother with me with too much web stuff. I get inundated looking at less than, greater than signs, more than like 20 occurrences per page. So that's HTTP fingerprinting. The GUIs and stuff I showed you about. Let's get back to the slideshow. Where is it? Screen size is too small. Okay, so that was the examples. Now I can skip. You saw that tool in action. Here's just a screenshot of the GUI. This is released today. You can download it from netsquare.com/httprint. We've got the Windows command line and GUI up there, Linux and OS X command line there. One thing about OS 10 or OS X is you have to have OpenSSL libs installed, because I don't think Apple allows you to generate static binaries for OS X. So that's the thing. Linux and Windows are statically compiled, and you can easily add signatures, extend this. Slick HTML reports, I already showed you. Uh, so now we will take a little break away from HTTP fingerprinting. I showed you what it is that I had to show you about. We will take all questions at the end because I know it's getting to be 6 o'clock. I have a couple of other things to talk about and demo. I clubbed all these things together as advanced assessment techniques. I did the same, similar set I presented up in the Seattle conference with the NTO Fire and Water Toolkit, which has all this stuff in it, by the way. So let me get on to the next subject, which is analyzing HTTP response codes. Excuse me. One of the things that is essential when automating web assessment or web analysis is your ability to recognize if something is a positive response or something is an error. Visually, we can tell what the difference is, if this is an error or not. But what does a program look at? All it has to look at so far is the HTTP response code. And it's a commonly established fact that 404 means not found, 403 means forbidden, 200 means okay, 500 means server error and such. What if you can customize your server, so instead of returning a non-existent error code, it returns something else. It returns, most of them return 302, say, oops, you typed in something wrong, but obviously you didn't know what you're doing, so you get redirected to Google. Go search for it yourself and don't annoy us. Or you could get a 200 OK saying, this is an error, but I'll still tell you that the page is OK. And sometimes this defeats crawlers, this defeats automated assessment techniques, defeats like the old versions of Whisker and such. And you can't really tell what's the correct result from a false positives. So how do we get around that? Well, we have a technique to deal with that as well called page signatures. The objective for page signatures is to accurately identify proper HTTP response codes, not based on the number that they return, but based on the semantics of the contents that was returned. Now, I don't do any pattern matching. I don't look for the keywords not found or any lame techniques like that. This is quite a different approach. You analyze web pages by frequency of text patterns occurring. It may be English, it may be anything else. So it's not dependent on any pre-built stuff. It minimizes false positives drastically, helps in automated testing, and page signatures are not only used to avoid false positives or errors. You can extend this to do things like find out which HTML pages are driven off a template, because every page driven off a template will have the same or similar, I should not use this word same, it will have a similar structure and appearance. And if it has a similar structure and appearance, the page signature will be the same. So page signatures help group things together, and they work more on similarity basis. Let me give you an example of what this is. So each HTTP response has a page signature. It's independent of the content in it, but based on how the content is laid out. It also has the ability to overlook random content. Like, if stuff is generated off a database or stuff is generated randomly, visually text patterns may be different, but the overall appearance is still similar. So this is what we overlook. Each page signature is a string of constant length. The blue bar below shows you an example of a page signature. It has a 3-digit response code, and I think it is a 32 hex-digit cryptographic junk. Okay, so just for a little bit of theory, the computation time for a page signature is order of n, where n is the number of bytes of the HTTP response. And the comparison time is order of constant time, because all you're doing is comparing 32 hex digits along with 3 numeric digits. So once you have page signatures, processing them is very fast. I have few examples. I shall just show you by means of a demo. So we have So you have a server over here called uh, Red October. Actually, sorry, Red Oracle. Okay, I'm just going to type some error request in here, stuff that doesn't really exist. And this is the error page that you get back saying, sorry, then there's a random number, says link you requested was not found. If I keep on reloading this, notice that the random number keeps on changing. So this is like my test case for randomized content. If we look at the innards of the HTML, I will show you that as well. We'll get some error stuff. Notice that it returns you with an HTTP 200 OK. So if you're running a crawler or something, and if this error response has randomly generated links with clear pixels and such, good luck trying to finish the crawl because the crawler is going to get hung in an infinite loop. If you run like an assessment engine, it's going to light up with every vulnerability under the sun saying, yes, this exists, yes, that exists. Like, I just took the classic case of Whisker, and I believe I might have an older version of Whisker, but just to illustrate the theory, not to be dissing Whisker or anything, I will run it against Red Oracle, and oops. Let me see what it does. It says the server was Netscape Enterprise, that obfuscated stuff, and every vulnerability in its database is coming back with a positive. That obviously is not correct. So let us see how we can use page signatures to overcome this hurdle. What we shall do is first derive the page signature of an error page. So I will say page signature red. Page signature, by the way, is not free. It's still under the works. I'm developing it for someone, for Mr. JD at the back. And you can use it in the fire and water toolkit that he puts out. You can use it freely, but you can't get to the innards of it, sorry. So I run page signature with just a junk URL. What I want to get is what does an error response from the server Red Oracle look like? I run this, and this is my error response. So let me just cut it and copy it into my clipboard for the time. I'll show you what we can use it for. Now I have like a Whisker lookalike scanner that I just threw together with a Perl script around Whisker. I'm going to run it against Red Oracle, and what it does, it tries to identify each resource, works just in the same way as Whisker, but also derives a page signature along with it. Now, to separate the fluff from the meaningful stuff, all we got to do is let this silly thing run its course, and oh, do shut up. I forgot to handle the control C in it. So all I have to do is run it, and I throw away all signatures which have the same error signature as we derived. So now it's only going to report genuine stuff that exists. So CGI bin test.cgi does exist because its signature differs from the error signature, no matter what the response code is. So there you are. This adds more accuracy in your automated tools. And one of the last things I will talk about after page signatures is like just a specialized application of page signatures. how page signatures can help us detect open proxies or reverse proxies. So just to give you a little brief about what reverse proxies are. Reverse proxies are web proxy servers that unfortunately work in both ways. You use a proxy from an internal network to send requests out to the internet and fetch them back. But sometimes they get left in bidirectional mode. So everybody from the outside internet can attach to your proxy server, make it like a proxy, and then walk all over your internal netted space. It's pretty fancy sometimes. It's like sometimes management interfaces like the old Compaq Insight Manager used to let people into their NAT space. Funny thing was, if you open the Compaq Insight Manager page, it'll give you the internal IP addressing on the web page itself. So goody. You don't have to try to brute force the private IANA space. You just walk right in. So here's an example of how things work. You have your front-end web server, which usually is dual homed or something. You send a request and use this to proxy back into your internal network. So I've got this bare test scenario set up, which lets me do that. So let me demonstrate that really quickly. Let me just show how it works. So I am on the 192 network, so I will connect to 192.168.7.238 port 8001, and I will say get HTTP. Now I already know the internal range, so I'm not going to waste more time in brute forcing it. I say get HTTP 10.0.1.2 HTTP 1.0. This is like sending a proxy request to 192.168.7.238 port 8001. Send a request for a server that lies inside. And when you do this, it comes back with saying, okay, HTTP 404 object not found, and it returned a response. That was a Lotus Domino server that we had. It's actually IIS with a server mask. So this indeed works, this reverse proxy. This is like how you do a reverse proxy. Now, how can we use page signatures to identify open or reverse proxies? Open proxies are the same, except that you use the proxy server to bounce off back into the outside internet. So I can set this IP address and port as my proxy and use that to surf the rest of the web, post comments on public sites with my IP address as that of the poor proxy owner's IP address, start sending spam mail through Yahoo, or play any dirty tricks that I want with somebody else's IP address. Open proxies are fairly dangerous because then you get into trouble, not the attacker. So the way to identify open proxies using page signatures becomes pretty easy. What you do is you take a reference site, something that remains static for more than the duration of the test. So you have, say, the front page of Google is a perfect example, small, compact, static site. You make a request to Google, get the contents, derive the page signature. And you make the same request for Google via the proxy server, and then derive the page signature again. If the signatures match, you got an open proxy. No fancy testing required, nothing else. It's like one technique can solve many problems. I've got sort of a Google-like site on this machine called Red October. So let me just open Red October. Okay, so this is like a mock-up of the Google site. We will use this as a benchmark. So what I have to do is derive the page signature of HTTP Red October. Comes back with signature, and I also coded up the tool to return the page signature via a proxy. So all I have to do is give it port IP address and port number, and it comes back with the same signature. And then, like, just for the heck of it, I wrote it into a little shell script called proxy detect. Oops. Anyway, dot 168.7.238. Okay, it returns the same thing. It says the signatures match, and therefore 192.168.7.238.8001 is an open proxy. If we say do this with a different port number, let's say the other web server, it returns two different signatures. Like directly it returns the genuine signature. Via the proxy it returns something else. So actually the proxy request failed. And therefore it says this is not a proxy. So that was about how to apply page signatures in reverse proxying or detecting open proxies. You can also do port scanning through proxies. Like if you know the internal range attached to a proxy server, start sending GET requests with different port numbers. If they come back as okay, you say these ports are open on the internal range, so on. I don't think I have too much time to demonstrate the other trick. But this was, the last slide was just to demonstrate how you can use the connect, HTTP connect through a proxy and tunnel in any arbitrary data to a port in the internal range. Okay, maybe I will demo it. To some it may be confusing because I don't have all the time to explain it, but why not even, since I have the mic and the stage, I'll show it. Anybody familiar with a tool called DataPipe? Came out a long time ago. I added some code to DataPipe. I'm going to make that public. It's a gimmick. What you can do, DataPipe opens up a listener on the system that it is running on, listens for TCP connections on that system, and forwards them on to another IP address and another port number. So it's basically, it's like, facilitator in the middle kind of a tool. What I've done is written DataPipe with HTTP proxy facilities to use the connect, to use HTTP connect to connect to an open proxy or a reverse proxy and start tunneling stuff inside and out. I think HTTP tunnel also does something similar to that. I was too lazy to go through the documentation of HTTP tunnel in order to make it work, so I thought I'd just rewrite DataPipe proxy instead. So you got, okay, I'll give you an example of how to attach to a VNC running on 10.0.1.2 when you're on 192.168.7.x network. So you open up a listener port, remote host is 10.0.1.2, remote port is 5900, the proxy host is 192.168.7.238, proxy port is 8001. Let's do that. Let me open up another window and run a little sniffer to show you what goes on. So in grep, oops, sorry. Okay, there we are. DataPipe is running. I will open up the VNC client. Okay, server is localhost. I just happen to know the password, so I'll demonstrate this. Of course, in the real life scenario, you'd be like doing all attack and penetration and cracking passwords and doing the glamorous James Bond thing to get in here. But I will just do this in 2 seconds. So you have, oh, well, there we are. VNC has worked. It's showing me the Windows screen already. I can, let me show you what the sniffer picked up. Let's kill the sniffer and go to the very beginning. See, all the data is now going over port 8001 between me and the proxy, and from then on, the proxy is tunneling it to so here is the opening connect statement. The DataPipe just established a connect to the internal IP address and port via the proxy. It says connection established. And then data pipe just hands over the rest of the TCP stream between my client and whatever it has connected to. So using HTTP, you can probably tunnel any protocol, whatever it is, terminal server, VNC, telnet, anything that you want, anything TCP, not UDP. So that was an example of this is VNC running. To prove it is working, I will log in. Yep, it's working. So anyway, I managed to cover everything. Yes. So okay, just to sum it up, all the work that I've done so far presented here is to facilitate automated web security assessment, the need for overcoming HTTP's customizable aspects, namely server banner strings and response codes. Of course, there's lots of good stuff in computer science, journals. All you got to do is pick it up, figure out what's going to work to solve this problem, and then go ahead and do it. This helps improve your accuracy, whatever. So closing thoughts, you can't patch or hide carelessness. Don't try security with obscurity. It shall not work for the smart people. And read good books. Shameless plug for my book. Thank you very much. Enjoy Las Vegas, and I'm open to questions for the next 10 minutes. Thanks. Question from the back. I could not hear you. Does HTTP print goes over SSL, or do I need to proxy that? It has SSL built in. It has SSL client functionality built into it. All you got to do is just either specify the URL as HTTPS, which will automatically put it to port 443 and SSL. If you have a different port, you'll have to just add the port at the end of the URL for the command line. Or if you're using the wonderful GUI, all you're going to do is tick the SSL box. So I thought of that, and I built it in. Any other questions? Yes, question. For page signatures, is my algorithm sending a request and getting stuff back? Is that? Okay, let me just explain that a little bit. Page signature works on the HTML response that is returned from any HTTP request. So all I do is pick up the response data, header and body, and then perform textual frequency, and like some of it borders on Fourier, discrete cosine transforms. Like what I want to do is detect how similar different areas are. So that's what I do, is I treat the text as a signal, a varying signal, and then do signal analysis. So that's geeky enough of a reply, isn't it? Damn, I'm impressed. Any more questions? Yes, yours. Am I planning to use the Apple GUI? Yes, I am. In fact, this is my opportunity to learn programming in Carbon. I bought a book 3 weeks ago, had to unfortunately prepare for black hat, so I couldn't get carbonized so much. It should be carbonized or carbonated, like Han Solo. But yes, I think the next time I speak, you might be seeing an OS X GUI. I love Apple GUIs, so you'll have that. It's like one of the things that I aspire to develop. More questions? None? Well, off you go. Enjoy Las Vegas.